Simplify monomials with exponents. So monomials are one-term pieces with no addition or no subtraction. So I'm going to teach you how to expand the expression, and then later we're going to distribute the exponent. So the difference between these two problems is important. So the first problem, evaluate the expression -5 in parentheses squared versus -6 without parentheses squared. So for number 1, that exponent 2 is directly on top of parentheses. So what that means is that you're going to take those parentheses and you're going to multiply them 2 times. If -5 is inside those parentheses, then you would do -5 times -5, which is positive 25, and that would be your answer. For number 2, on the left side, that exponent is on top of the number 6. There are no parentheses. So that exponent 2 says you are multiplying 6 times 6. If there is a negative in front of that expression, that negative goes in front of that multiplication. 6 times 6 is 36, and then we have a negative lying out there, so it's negative 36. Another way you could think about this is you can force parentheses around the actual 6 because the 2's on top of the 6. If you understand that that number by itself is being expanded, you can take that negative outside and put your hidden mathematical number. So if there's a negative multiplied, technically it's a -1. So you can write it out like that if it's going to be more helpful. So this problem is a monomial, but it's not just one piece. There's multiple things happening here. So we're going to expand and do the same thing. So if the exponent is 2, that 2 is on top of parentheses, which means we're going to take the entire parentheses and multiply it twice. There is nothing outside the parentheses, so I'm not going to worry about that. So I have 3a to the 5th, b to the -3, times 3a to the 5th, b to the -3. So the rules for multiplying monomials, the numbers we just multiply as is. So we have 3 times 3. That's going to give us 9. A to the 5th times a to the 5th. We add those exponents. So 5 plus 5 is 10. And then for the b, again, that's being multiplied. So it's -3 plus -3. So your answer would become 9a to the 10th, b to the -6. You cannot have negative exponents, which means this b to the -6 is not okay. So what we're going to do is we're going to leave our 9, we're going to leave our a to the 10th. That b to the 6th, just that, has to be written as a fraction. 1 over b to the +6. And if we already have a numerator, which in this case is going to be the 9a to the 10th, we could just take our b to the 6th in the denominator and write it like that. Now there is a quicker way of getting from the answer, or from the problem to the answer, and that's by distributing the exponent. So another option, you could take that exponent and distribute it. The only issue is some people forget that everything, when you distribute, it has to multiply everything. So that 3 has an exponent of 1. So it would be 1 times 2. The exponent of the a, 5, would be multiplied by 2, and the b would also be multiplied by 2. Which means you're left with 3 squared, b to the 10th, a to the 10th, and then b to the negative 6th. 3 squared is 9, a to the 10th, and that negative exponent has to go in the denominator as b to the 6th. So you could still get that same answer.